This is chapter 6, section 3, number 36. So we have three functions given us. So we have ln of x. We're told y equals 0, which is the x-axis, x equals 0, which is the y-axis, and y equals 2, it's actually 4. So you got this region here, and they're telling you rotate around the y-axis. So let me zoom in a bit and show you what this is going to look like if we rotate this. I'm sticking with the green. And at the bottom, you would get a disk here. No, that's not a disk. Try it again. The bottom, you'd get a disk. No. Third time's the charm. Come on. Come on. Yes. Okay. And as you go up, you're going to get more and more. Whoa, what just happened? Trying to get this positioned. At the top, you're going to have a disk. And this one's going to be huge. No, it's mocking me. Okay, third time's a charm. Make it nice and round and it'll reward you. No, that was, okay. I don't know why it's so crazy. It should be, there we go. There we go. I did it. I did it. So there's another disk, and then I'll draw another, and hopefully I can get this on the first shot. Let me round off the corner. Ooh, that was not supposed to happen. Start down here. Nice and round, and it makes a disk. Bam. So we have these going up and down the whole thing. So there are infinite number of disks, and we want to add them all up. So what's our volume? I don't know how that happened. The volume, we add them up. What's the volume of a disk? It's pi, and I'm going to do r1 squared because the r is used already. And where's my first disk? Right here at y equals 0, and the last one is at y equals 2. So I'm going to add up the disks from 0 to 2. But the question, oh, and the thickness of the disk. The thickness here is a change in y as you move up and down. So you need to know that that is dy. If you don't, you need to come visit me and get some help. Okay, so pi, we got to figure out r, or r1 in this case. So let me back out or zoom in. What does r look like? So r always goes from the axis of rotation to your function. Let me draw the axis of rotation in here again. So from the axis of rotation to our function. So when I draw it, it's going to go from there to there. And this is going to be my r1. But in this case, since it's horizontal, it's going to be the big X minus small x. And where's big X and where's small x? If you're confused again, you need to come and get help. We know on the number line, to the right are bigger numbers, to the left are small numbers. So it's this black function minus the y-axis. Okay, how am I going to do that? Well, you might say, I know this line. This line is ln of x. So big X is ln of x. Wrong. On this line, y equals ln of x. I don't want y, I want x. I need to solve for x. How do you get rid of ln? You all should know the inverse of ln is e to the x. So I e both sides to get those to cancel, and that leaves me x equals e to the y. This is big X. So big X is e to the y. Small x is the y-axis where y equals 0, so minus 0. So R1, in conclusion, is going to be e to the y. So back here, it's pi e to the y squared dy. I have 1 minute to finish this. This is crazy. So it's going to be pi 0 to 2 e to the 2y dy. This is not a function, so I have to replace it with u. Du will be 2 dy, but here's my problem. I don't have 2 dy, but I can magically get it by multiplying by 2 here and a half here. And so I have pi over 2 e to the u du. This became du, and this became u. But these are y's. I have to change them to u's. So let's do that next. When y is 0, u is still 0. When y is 2, u would be 4. All right, so I'm almost done here. It's e to the u from 0 to 4, which is e to the 4 minus pi over 2 e to the 0, which is just 1. So we just factor out the pi over 2 and we get e to the 4 minus 1. And that is that problem.